Next, we're going to add more control to the car's steering function. First, we need to apply an aim constraint to the steering controller. Why do we need an aim constraint? Because generally when we animate a car, we create a path and make the car move along this path. If I draw a path here, we can imagine the car is at this position now. If I put another point in front of the car and make the steering controller, this controller always point at this point in front. Wouldn't that achieve an auto steering effect? So based on our description, we want the steering controller to always point at one place. When we hear this description, we should definitely use an aim constraint. This point in front will be our controller. Later on, we will take this controller and the car's main controller and attach them both to the curve, so they move together, while ensuring this front controller is always ahead of the car. This will achieve the steering effect. Let's do this together. First, create a controller. Let's hide the model for a moment. Then use the CV curve tool in linear mode. Switch to the side view. We'll draw an arrow. We'll call this arrow turning aim. Then group it. Show the model again. Then let's snap it to the position of the steering controller itself. And from there, move it forward. This ensures they are at the same height. Let's scale it up a bit, freeze transformations. Let's also set its color to yellow. Next, we need to apply an aim constraint to the steering controller. Let's see. We obviously can't apply a constraint to our controller itself, because this controller still needs to be left for the animator. So what do? We'll add another group above it. Let's give this group a different name, call it driven. This indicates it's driven by other objects. We generally apply constraints to a group like this. Let's apply an aim constraint. We'll use this group above it as a reference and copy its zero group's name. Then select the controller, select the driven group aim constraint. Let's check here. We're using the z-axis as the aim vector and the y-axis as the up vector. Here we'll use object rotation up. Because the reference object is at the same position, we'll use the reference object's y-axis as the reference up vector. Click Apply. This way, the steering controller will move along with the arrow controller. But the problem is, when the controller moves up, we'll see the steering controller also rotates upwards. This is not what we want, because only the controller's rotate Y should affect the steering. So what do? We need to change the aim constraint. We talked about this before when discussing aim constraints. If we lock the aim vector and move the up reference object, we can achieve single axis rotation. We'll use this idea here to get this behavior. Create a new group. Snap it to the driven group's position. Then put it under the zero group as its child. Then move it up along the y-axis. Move it 150 units. It doesn't matter how far we move it, as long as it's higher than the driven group, because we need the driven group's y-axis to point at this new group. Let's rename it. This way, we have the new target object. Then we use it to apply an aim constraint to the driven group, and use the controller we created earlier as the up reference object. This way, we can get the y-axis rotation value without affecting the other axis. Let's do it. Let's copy the name of this arrow controller. Then select the group we just created. Select the driven group. Then click Aim Constraint. Let's check here. Y-axis is the aim vector and z-axis is the up vector. Then select Object Up here. And the reference object is the controller we just created. Now look, when we move the controller up, it no longer affects the rotation. And only when moving along the x-axis will it affect the rotation. This achieves the steering effect. Let's also put this controller under the back controller at the same level as the steering controller itself. We'll see some problems here. The first problem is, when I move the controller like this, the steering controller does rotate, but it doesn't affect the wheel steering. Why? Because if we remember, the wheel steering is driven by the connect group. What is the connect group connected to? It's driven by the sum of the steering controller's rotate Y and the steering wheel's rotate X. No matter how we change the arrow controller, it only affects the group above it. It has no effect on its own Y-axis value. So we need to factor in the parent group's rotate Y as well. This way, let's select those two connect groups. Open the node editor. Then show the input nodes. We use an add double linear node here. We can simply add the driven group's rotate Y to it. But the add double linear node only has two inputs. So we have two methods here. We can either create another add double linear node and take the first add double linear node's output and add it to the driven group's rotate Y, and then connect that to the connect group. Or we can create a plus minus average node. We've talked about this node before. It has more inputs for us to connect to. So let's create one. Change the name. This way, let's take the original steering controller's rotate Y and connect it to input 1D0. Then connect the steering wheel's rotate X to input 1D1. Then the steering controller's parent group's rotate Y connects to input 1D2. Then let's connect this over. Use output 1D to connect it. Now we can delete the original add double linear node. This way, let's check again. Here, we've achieved the wheel steering effect. But there's still a problem. When we rotate like this, we'll notice the steering wheel doesn't turn with it. Why? Same reason. Because the connect group above the steering wheel is also only driven by the steering controller's rotate Y. So let's create another add double linear node to add them together. Find the parent driven group and add it. Connect both rotate Y values. Then connect this to rotate X. This way, let's check again. When I move the arrow controller, we'll see the steering wheel also rotates along with it. Let's clear the node editor. Then close the node editor. Next, something I'm not happy with visually is this controller right now doesn't feel like it's connected to the car. Because this controller, we might pull it very far away. In that case, I might not even know if it's a controller for this rig, because there might be many rigs in the scene. So what do? I want to draw a line between this controller and the model. This way, no matter how far I pull it, there's a line connecting them, which will always remind me it's a controller for this rig. So how do we do this? Maya has actually given us a great tool to do this. What is it? In Create, find Annotation. Click it. Then just create one. Here we'll see a line and a label on it. This label is the text from the input field. We don't need this text, we just need the arrow. So what do? We select the controller, then in Create, find Annotation. We won't enter anything here. Then select OK. This way, we will create an arrow that doesn't display any text. It creates two nodes. One is a locator, and below it is its own shape with a transform node. This way, when we move it, the whole line will move with it. Let's rename these two first. Then we select the steering controller, select its bottommost node, and apply a point constraint between them. No maintain offset. This way, the line is snapped to the front of the car. And when we move the controller, there will always be a line connecting them. But there's a problem. This line can be selected right now, and we don't want the animator to touch these two nodes. So we select the corresponding node, find its shape node, and in Object Display Drawing Overrides, change it to Reference. Same for the other node. Find the shape node and change it. This way, this line won't be selectable. Let's also do a cleanup on this controller, because we will need to connect this controller to the curve. So to make it easy to connect, we'll keep both translation and rotation, and lock and hide the remaining attributes. This way, when we need to do a parent constraint, we don't need to click extra attributes like skipping translation or skipping rotation. And with that, the aim controller we added for the steering function is complete.